August 16th, 2020. As the world looked the other way, an asteroid just 3 meters wide slipped through the darkness, passing between Earth and the Moon at a jaw-dropping 2,950 kilometers from our planet. No alarms, no early warnings. For 6 hours, nobody even noticed. This was not just Earth's closest call on record. It confirmed a terrifying truth about how blind we really are. The story begins the moment someone finally spotted what they had already missed. At the Palomar Observatory in California, the routine hum of the Zwicky Transient facility masked the fact that history had already changed course 6 hours earlier. On August 16th, 2020, the automated survey swept its camera across the sky, capturing a long, faint streak on a digital image. The timestamp read 1808 UTC. The asteroid had already come and gone, its closest pass at 1208 UTC, slicing just 2,950 kilometers above Earth's surface. The discovery did not start with a blaring alarm. Instead, it began with a quiet review of images by a trio of student researchers, Kunal Deshmukh and Kriti Sharma from the Indian Institute of Technology, Bombay, and Chenyen Xu from National Central University in Taiwan. Their job was to sift through hundreds of nightly images, each crowded with streaks from passing satellites and traces left by cosmic rays. That night, Deshmukh paused at something that did not match the usual clutter, a streak that hinted at something moving fast, something close. They flagged the image for further review. The Minor Planet Center received the alert and assigned the official designation 2020 QG. Only then did the realization sink in. The asteroid had not just flown close, it had threaded the needle between Earth and the Moon, unseen, before anyone had a chance to react. 6 hours had passed since the moment of closest approach. 6 hours where the world remained oblivious to just how near we had come to a cosmic brush. On that day, the clock started ticking long before anyone even noticed there was a clock at all. Asteroid 2020 QG did not just slip past Earth, it shattered records. According to NASA's Jet Propulsion Laboratory, this small rocky visitor came just 2,950 kilometers above our heads. That is not a typo. Commercial airliners cruise at about 10 kilometers. The International Space Station orbits at 400 kilometers. Even our geostationary satellites, the workhorses of global communication, circle at 35,786 kilometers. 2020. QG passed so close that if you stacked 7 International Space Station orbits end to end, you would still be short. For decades, scientists at the Jet Propulsion Laboratory and the Center for Near-Earth Object Studies have kept a meticulous ledger of cosmic near misses. Before 2020 QG, the closest non-impacting asteroid was 2011 CQ1, which skimmed by at 5,460 kilometers. 2020 QG beat that record by more than 2,500 kilometers, a margin that in space terms is razor thin. Paul Chodas, who manages the CNEOS database, confirmed, "This is the closest pass we have ever recorded for a known asteroid that did not hit." Size matters in these encounters. 2020 QG measured just 3 to 6 meters across, roughly the length of an SUV. If it had struck Earth, it would have disintegrated in the atmosphere, lighting up the sky as a fireball. No ground damage, just a fleeting spectacle. But the numbers do not just stun, they reveal a vulnerability. For everyone we catch, how many slip past unnoticed? The record books can only tally what we see. The real margin is invisible, and that is what keeps planetary defense experts awake at night. Asteroid 2020 QG approached Earth from a direction that is almost impossible for ground-based telescopes to monitor, straight out of the glare of the sun. Most optical surveys are designed to avoid pointing anywhere near the sun. That is not just a matter of safety for the equipment. Solar glare floods the sky with light and overwhelms the faint signatures of small, fast-moving objects. During daylight, the sky is so bright that even the most powerful telescopes are effectively blind to anything coming from that corridor. For 2020 QG, that corridor was narrow, an invisible slice of sky where the asteroid could travel undetected, shielded by the sun's brilliance. The asteroid was moving at about 12.3 kilometers per second, or about 27,500 miles per hour. At that speed, 2020 QG crossed the distance from the edge of the moon's orbit to Earth in just a matter of hours. The combination of its velocity and the angle of approach meant that by the time the Earth rotated enough to put the asteroid against a dark sky, it had already passed by. Telescopes like the Zwicky Transient Facility only caught it after the fact, when the sun was finally out of the way, and the asteroid was already heading back out into space. This is not a rare fluke. The geometry of Earth's orbit and the limits of optical technology create a persistent blind spot, a wedge of sky always near the sun, where asteroids can slip through completely unnoticed. Until our detection systems can look sunward, these invisible corridors will remain a weak point in our planetary defense. 10 years before 2020 QG's silent flyby, a different asteroid gave the world a brutal demonstration of what even a small space rock can do. On a cold February morning in 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia. The blast shattered windows across 6 cities. More than 1,500 people were injured by flying glass and debris. Thousands of buildings needed repairs. The Chelyabinsk meteor arrived with no warning. It came from the direction of the sun, a blind spot for Earth-bound telescopes. Impact physics expert Peter Brown later calculated the energy released at nearly half a megaton of TNT. That is more than 30 times the force of the Hiroshima bomb, unleashed by a rock barely larger than a delivery truck. Events like Chelyabinsk are not rare in cosmic terms. NASA and the European Space Agency estimate that about 90% of the truly massive, kilometer-wide asteroids, objects big enough to end civilizations, are already cataloged. For these giants, the risk of a surprise is low. But for smaller asteroids, the ones that could flatten a city or injure thousands, the picture changes completely. Less than 10% of near-Earth asteroids larger than 140 meters are tracked. For objects the size of Chelyabinsk or smaller, the vast majority remain undiscovered. Thousands of these space rocks cross Earth's orbit every year, many slipping by unnoticed. The numbers reveal a gap in our planetary defense, a gap measured not just in kilometers, but in lives and cities at risk. The next leap in planetary defense is happening above the clouds. The Near-Earth Object Surveyor mission, led by Dr. Amy Mainzer, is designed to spot what ground telescopes can't: asteroids sneaking in from the direction of the sun. Instead of relying on reflected sunlight, Surveyor uses infrared sensors to detect the heat these space rocks emit. Even a small dark asteroid glows in the infrared, making it stand out against the cold backdrop of space. Placed in a solar orbit between Earth and the Sun, the spacecraft will scan for objects as small as 140 meters, city killers that could slip through our current blind spot. Scheduled for launch later this decade, Surveyor promises to close the gap that left us vulnerable to near misses like 2020 QG. With this technology, astronomers will not have to wait for the night sky to reveal what is coming. They will see the heat signature before danger arrives. Proof that planetary defense is possible arrived in 2022 when NASA's Double Asteroid Redirection Test, DART, struck its target. The Johns Hopkins Applied Physics Laboratory team sent a spacecraft hurtling into Dimorphos, a small moonlet orbiting the larger asteroid Didymos. The result was not subtle. DART's impact shortened Dimorphos's orbit by 32 minutes. For the first time, humans had deliberately changed the path of a celestial body. The experiment did not just demonstrate that deflection works, it proved that, with enough warning, we can actually protect our planet from an incoming threat. But there is a catch. DART's success depended on years of preparation and advanced tracking. Deflection only works if we spot the danger early. Without that crucial lead time, without the warning that detection provides, even the best technology is powerless. The science is now proven. The challenge is making sure we see the next one in time. Right now, thousands of unseen asteroids are still out there, some traveling sunward, invisible until it is too late. Our technology is racing to catch up, but the clock is always ticking. Vigilance is not optional, it is survival. In cosmic terms, preparedness is the only real protection. Stay curious and stay watchful.